Welcome back, everybody. Today we are going to be simplifying the following inequality. So when I first looked at this inequality, something stuck out to me. Can anybody tell me what stuck out to me? Yes, you're right. That absolute value, that we are going to have to deal with an absolute value. I used to think absolute values were easy. As we get up there in math, I feel like absolute values get a little trickier, if anything. So yes, we have an absolute value we are needing to work with. Since we have an absolute value, we know there's two caseworks we have to go through because we know what absolute value is. Absolute value is what? Who can help me out? Yes, that's exactly what it is. It's the distance away a number is from zero on the number line. So if this is our number line, 2, the absolute value of 2 is 2 because it's 2 away from 0. However, the absolute value of -2 is also 2 because it's 2 away from 0. So when we're working with an absolute value, we have to take into account both that positive and that opposite scenario. So the first thing we want to do is we want to get to a critical point where we can solve for that positive and negative, okay, inequality according to that absolute value. So the first thing we want to do is we just want to get that absolute value by itself. That's our critical point for today. That's where we want to start solving both ways from. So to do that, what's the first thing we need to do? I heard it. We need to get rid of that 3x. And hopefully we remember how to do that. We need to look at what we're currently doing to that 3x. What are we currently doing? You got it. We're currently subtracting. So to get rid of the 3x, to move it to the other side, what do we need to do? You got it. We need to use inverse operations. So we were subtracting 3x. Now we're going to add 3x to both sides. So that cancels out our 3x on one side. So all we're left with now is that 2x minus 3. And notice that I did not put the 3x underneath the 1 because they cannot be combined. They are unlike terms. So this is what we're going to be starting with. However, like we just said, there's two caseworks because we're dealing with an absolute value. We need to do the opposite of that. So we need to take our 2x minus 3, and then we need to do the opposite of that 1 plus the 3x. Okay, and we need to work it both ways and see which one works for us. So now let's go back over to the purple side. And now what our goal is to get our variables on one side and our constants on the other. And if you forget what that word constant means, that just is that single number all by itself, no variable attached. I see you guys. Yes, you're saying we need to get rid of the -3. And we get rid of the -3 by doing what? Yes, inverse operation. So we're going to add the 3 to both sides. And so now let's simplify it down. We're left with 2x and we can change that to equals 1 plus 3 is 4 plus 3x. Are we done? No, math is never that easy, is it? We got a variable over here. We have a coefficient and variable over here. What are we going to use? I heard subtraction. Yes, because that is the inverse operation. So we're going to subtract that 3x on both sides. When we do that, those cancel out. 2 minus 3 is -1x equals 4. And we know when we have 1 of something, we can really just delete the 1 and make it -x equals 4. Well, I don't like that -x being there, so I'm going to get rid of it by multiplying both sides by the opposite. So now a negative times a negative is a positive x equals -4. On this side, we got -4. We will go back and check at the end, okay? So now we want to switch gears, and I'm going to break down the other side. So now I think it's easiest to rewrite the problem with that opposite having been reached out. It does not want to change my color to red, and I really want it to change to red. There we go. So we're going, no, it didn't. Let's see if it still didn't. It says it. 2x, there it goes, -3. And then I want to multiply that negative out. So a 1 times a negative is a negative 1. And then our plus is going to change into minus 3x. So what's our next step? You got it. Inverse operations to get rid of that 3. So I'm going to add the 3 right underneath here. 3's cancel out. We're left with 2x equals negative 1 plus 3 is 2 minus the 3x. I heard you. Yes. You guys are answering my questions before I even ask it. What's the next step? Yes, we need to get rid of that 3x by adding it this time because we need to do the inverse subtraction, which is adding. So we're left with 5x equals 2. Are we done? No way. We don't have x alone yet. What's our last inverse we need to do? Correct. We need to divide each side by 5 because we're currently multiplying by 5. So now we're left with x equals 2/5. And for this, I would change 2/5 into a decimal point. I just find it easier to work with. So 2/5, I can change into decimal real quick. We times 5 by 20 to get to 100. And then I can times by 20 to get to 40. I can cancel those and I'm left with 0.4. You could also do 2 divided by 5 and get that 0.4 as well, okay? So then, great. So now that we have both cases laid out, we need to go back to the original equation and put it in. So the first thing we're going to be doing is going back to that absolute value of 2x minus 3 minus 3x is less than, or excuse me, is greater than 1. That alligator's eating that side. I should know better than that. So I'm going to put in negative 4 for the x. And then I'm going to simplify that down. 2 times negative 4 is 8. Negative 8 plus a negative 3 would be negative 11, but it's absolute value of 11. And then a negative, because I can turn this into negative, negative 3 times negative 4 turns out to be a positive 12. So then we take 11 minus 12 and we get a negative 1. Is negative 1 greater than 1? No, it's not. So that side didn't work. So this is why I went ahead and turned 2/5 into decimal. You can either just divide 2 divided by 5, or you can make it into percent and change it to decimal from there. Is when we put it back in the equation, it's just a little bit easier to work with. So we need 2x minus 3 minus 3x is greater than 1. So this time I'm just going to stick in, sorry, what it wants me to extend the page. 2 times 0.4 minus 3, and then 3 minus 0.4. So when I do this, I do 2 times 0.4, and I can just do it in calculator. 2 times 0.4 is 0.8, and then minus the 3 is 2.2. But since it's the absolute value, it's negative 2.2. But since it's the absolute value, it is just normal 2.2. Minus 3 times 0.4 is 1.2. 1.2. So then we can subtract 2.2 minus 1.2 is 1. So we have our solution. Okay, 1 is equal to 1. So now we have to decide is if x is less than 2/5. Whoa, it's going crazy. X is less than 2/5, or x is greater than 2/5. So what I did was I just went through and I worked the problem instead of with 0.3, instead of 0.4, is I put a 0.3 in here. And then when I did that, I got 2 times 0.3 minus 3 is negative 2.4, but it's a positive, remember? So I'm just kind of writing over this. And then minus 3 times 0.3 is 0.9. So this would be minus 0.9, 0.9. So when we do 2.4 minus 0.9, we get 1.5. 1.5 is greater than 1. So we would know that we want x to be smaller, because when we tried it out with smaller fraction than 2/5, because when we did 2/5, it was exactly 1. So we know we need to get smaller because it actually raises that answer up. Okay, I know that took me a little bit more time. Technical difficulties, I tell you what. I hope you guys have a great evening. You guys did a great job, and I look forward to seeing you guys again soon. Have a great time. Bye, you guys did great.